The Hartle-Hawking no-boundary proposal. Every theory about the cause of the Big Bang runs into the same wall. The moment you ask what came before, you assume that time already existed before the beginning. But Stephen Hawking and James Hartle propose something that shatters that assumption entirely. What if time itself did not exist before the Big Bang? What if asking what caused it is as meaningless as asking what is south of the South Pole? The no-boundary proposal begins with a radical reimagining of time. In ordinary life, time is an arrow, a straight line stretching infinitely in both directions. But Hartle and Hawking propose that near the Big Bang, time was not a line. It was behaving like a spatial dimension. To make this mathematically tractable, they introduced the concept of imaginary time, a mathematical rotation in which the dimension of time and the dimensions of space become geometrically interchangeable. In imaginary time, the universe has no edge, no boundary, and no beginning. Its geometry near the origin resembles the surface of a smooth sphere. Just as you can travel along the surface of the Earth in any direction and never hit a wall or fall off an edge, the universe in imaginary time has no sharp starting point. It simply curves back on itself. The Big Bang, in this framework, was not an explosion triggered by a cause. It was the geometric point where imaginary time transitioned back into real time, the moment the smooth, boundaryless curvature of the early universe crystallized into the linear, forward-marching arrow of time that we experience. There was no moment before it, because the concept of before requires real time to already exist. The most unsettling implication is philosophical. We demand a cause for the universe because every event in our experience has a prior cause. But this intuition is built entirely on the foundation of real time. Before the Big Bang, real time did not exist. There was nothing to do the causing. The universe did not need a cause. It needed only a geometry, and the geometry it had was one with no beginning, no edge, and no room for the question we most desperately want answered. Number 7. Vilenkin's tunneling from nothing. In 1982, the physicist Alexander Vilenkin proposed something so audacious that it bordered on metaphysical. He suggested that our universe did not evolve from a prior state. It did not emerge from a quantum vacuum that already existed. It did not bounce from a previous cosmos. It tunneled, instantaneously and without a cause, out of a state of absolute, literal nothingness. To understand quantum tunneling, consider a particle trapped inside a potential barrier, an energy wall it classically cannot cross. It does not have enough energy to climb over the wall, so in classical physics, it is permanently imprisoned. But in quantum mechanics, the particle does not need to go over the barrier. Because its position is described by a probability wave rather than a fixed point, there is a non-zero mathematical probability that the particle will simply appear on the other side. It does not travel through the barrier. It ceases to exist on one side and begins to exist on the other. This is not a metaphor. It is a measured, confirmed phenomenon that powers the nuclear reactions inside the sundae. Vilenkin applied this principle to the universe as a whole. He modeled the ultimate state of nothing, not empty space, not a quantum vacuum, but the complete absence of space, time, and energy, as a mathematical state with a wave function. According to the equations of quantum cosmology, this state of absolute nothingness is quantum mechanically unstable. The wave function describing nothing has a non-zero amplitude on the other side of the barrier, the side where a small, closed universe with a non-zero radius exists. The universe tunneled into existence. Not from something, from nothing. There was no prior state, no collapsing ancestor, no inflating background. The geometry of space-time itself, along with its energy, its matter, and its time, appeared in a single quantum event, in the same way a radioactive nucleus simply decays without any external trigger. The cause of the Big Bang, under Vilenkin's framework, is the intrinsic quantum mechanical instability of non-existence itself. Nothing, it turns out, cannot stay nothing forever. Number 6. String gas cosmology. Every origin theory we build assumes that the universe started from a state of chaos, heat, and rapid expansion. But what if it started from the opposite, a state of maximum constriction, governed by a radically different kind of physics that only string theory can describe? String gas cosmology, developed by Robert Brandenberger and Qumran Vafa, begins with a principle unique to string theory called T-duality. In standard physics, if you compress a region of space down to an infinitely small point, the energy density inside that region becomes infinitely large, a singularity, a breakdown of the math. But strings are not point particles. A string wrapped around a circular dimension has two distinct modes of energy: the vibrational energy of the string itself, and the winding energy of how many times the string wraps around the compact dimension. As the dimension shrinks, the winding energy increases. But crucially, T-duality dictates that a universe with a radius of r is physically identical to a universe with a radius of 1 over r. There is a minimum meaningful size, the string scale. You cannot compress space below it, because below it, the physics is a mathematical mirror of the physics above it. In string gas cosmology, the universe did not begin with a Big Bang. It began in a hot, dense, and static state, the Hagedorn phase. The universe was a tightly wound, oscillating tangle of strings, trapped at the string scale, unable to expand, because the winding modes of strings wrapping around the compact dimensions were holding everything in place. It was a cosmic stalemate. Strings wound around dimensions prevented those dimensions from growing, and the dimensions were too small for the strings to annihilate. Then, through statistical interactions, the wound strings began to find their anti-wind partners. As they collided and annihilated, the winding modes that had been strangling the dimensions disappeared. 3 specific spatial dimensions were suddenly free. They began to expand. This selective release, only 3 dimensions expanding while the others remained wound, is string gas cosmology's proposed explanation for why we live in a universe of 3 spatial dimensions, not 10. The Big Bang was not an explosion from a singularity. It was a phase transition. It was the moment the cosmic deadlock of wound strings finally broke, releasing 3 dimensions to grow into the universe we inhabit today. Number 5. Black hole baby universe. Stellar evolution tells us that when a star of sufficient mass exhausts its nuclear fuel, its core can no longer withstand the crushing inward pressure of its own gravity. The star collapses, condensing millions of Earth masses into a sphere smaller than a city, and eventually down to a single point. This is the formation of a black hole, harboring a central singularity, a mathematical anomaly where density approaches infinity and the known laws of physics effectively break down. But the physicist Lee Smolin proposed a paradigm shift that turns the ultimate graveyard of matter into a cosmic incubator. What if a singularity does not represent the end of space and time, but rather a violent localized rupture? In this theoretical framework, the extreme compression of matter at the heart of a black hole reaches a critical threshold. Instead of collapsing into an infinitely dense, dimensionless dot, the fabric of space-time undergoes a dramatic topological change. The immense gravitational pressure forces a bounce. However, because the gravity is too intense for the matter to bounce back out into the parent universe, it punches a hole through the spatial fabric, expanding outward into an entirely newly created region of spacetime. To an observer inside this newly formed region, the event would appear as an explosive genesis, a sudden outward rush of incredibly dense, hot matter and expanding space. It would look exactly like a Big Bang. This leads to a staggering evolutionary hypothesis known as cosmological natural selection. If universes are born inside black holes, then universes that generate more black holes will have more offspring. The fundamental constants of physics, the speed of light, the strength of gravity, the mass of electrons, would be subtly altered during each birth. Over countless generations, the multiverse would naturally select for environments finely tuned to produce stars, galaxies, and black holes. Our universe is incredibly efficient at building black holes, which implies we are far down the evolutionary lineage of a sprawling, reproducing cosmic family tree, our own genesis sparked by the death of a giant star in a universe completely inaccessible to us. Number 4. Causal dynamical triangulation. Every theory of the Big Bang faces a foundational crisis. The equations of general relativity and quantum mechanics are mutually incompatible. To describe the origin of the universe, we need both simultaneously: gravity at its most extreme, operating at scales so small that quantum mechanics dominates entirely. This breakdown is the singularity problem. The equations simply stop working. Causal dynamical triangulation, CDT, attempts to solve this not by adding new particles or hidden dimensions, but by rebuilding the very fabric of space-time from the ground up, using quantum building blocks. In CDT, space-time is not a smooth, continuous surface. It is assembled from millions of tiny, four-dimensional geometric building blocks called simplices, the four-dimensional analogy of triangles. Each simplex is a Planck-scale chunk of spacetime, possessing a definite shape and a definite causal orientation. There is a clear direction of before and after built into the geometry of every block. This causal constraint is the critical innovation that separates CDT from earlier, failed attempts at quantum gravity. Prior models allowed spacetime to fold backward on itself, creating geometrical chaos. CDT forbids it. When physicists ran computer simulations of these Planck-scale simplices, letting them combine and interact according to quantum mechanical probability rules, something extraordinary happened. The random assembly of billions of causally constrained geometric blocks spontaneously produced a smooth, four-dimensional spacetime that closely matches the large-scale structure of our universe. Space and time did not need to be assumed. They emerged from the self-organization of a quantum geometry. The implication for the Big Bang is profound. In CDT, the universe was not caused by an explosion. It was caused by a phase transition in the underlying quantum geometry, a spontaneous reorganization of Planck-scale building blocks from a state of chaotic, crumpled geometry into an ordered, smoothly expanding spacetime. The Big Bang marks the boundary between two phases of reality, the disordered quantum foam that came before, and the structured, causal, expanding universe that followed. We did not begin with a bang. We began with the universe crystallizing into coherence. Number 3. White hole eruption. General relativity permits a variety of bizarre geometrical configurations in spacetime. We are highly familiar with one, the black hole, a region where gravity is so intense that matter and light can enter, but absolutely nothing can leave. The mathematics, however, function flawlessly in reverse, predicting the exact opposite structure. A white hole is a localized region of spacetime that nothing can enter, but which violently ejects matter, light, and energy outward into the void. While black holes form from the collapse of massive stars, the formation of a white hole requires a mechanism completely alien to our local physics. This is where the concept of the Einstein-Rosen bridge, a wormhole, provides a critical narrative connection. Suppose in another, older universe, an unfathomably massive black hole forms. It consumes vast quantities of surrounding matter, gas, and entire star systems. As this material falls past the event horizon, it is drawn down a deep gravitational funnel. Instead of terminating in a singularity, the throat of this black hole extends, curving through the higher dimensional bulk, forming a bridge to nowhere. The immense pressure and relativistic dynamics of the funnel eventually rupture into a nascent region of spacetime. The output valve of this interdimensional pipeline is a white hole. If you align the mathematics of a white hole eruption with the observational data of the Big Bang, the parallels are striking. Our universe began as a sudden, torrential outflow of matter and radiation from a highly localized, fiercely dense region. In this scenario, the origin of our time and space was quite literally an exhaust event. The expanding plasma that eventually cooled to form our galaxies was simply the recycled debris of a separate universe, funneled through a cosmic bottleneck. We are living inside the aftermath of an interdimensional pressure release, our entire reality unfolding entirely within the event horizon of a colossal, cosmic output valve. Number 2. The Gottlieb self-creating universe. Every model of cosmological origin eventually runs into the same logical wall. If the universe was caused by X, then what caused X? If X was caused by Y, what caused Y? The chain of causation retreats backward in an infinite regression that science cannot resolve. The physicist Richard Gott III and his colleague Li-Shin Li proposed a solution so radical it seems like a logical paradox, and then proved the mathematics might actually work. What if the universe created itself? Gott and Li's model exploits a feature of general relativity that is deeply uncomfortable to intuition, the possibility of closed time-like curves, or CTCs. In standard spacetime, causality is enforced. Cause always precedes effect because time only flows forward. But Einstein's equations do not actually forbid time loops. Under extreme conditions of spacetime curvature, it is mathematically possible for a region of spacetime to curve back on itself in time, forming a loop in which an event can be, in principle, its own ancestor. In the Gottlieb model, the very early universe was not expanding from a singularity. The earliest moments of spacetime existed in a region of CTCs, a self-consistent, causally looping region where the boundary between cause and effect dissolved. The universe, in a precise mathematical sense, gave rise to itself. The Big Bang did not require a prior cause, because the expansion that followed eventually looped back through the geometry of early spacetime to seed the very conditions that generated it. This is not a violation of physics. It is not magic. Gott and Lee demonstrated that such a structure is consistent with Einstein's field equations and does not produce the paradoxes one might expect. A universe bootstrapped into existence through its own causal loop is self-consistent in the same way that a logically closed system can be consistent without any external foundation. The unsettling philosophical implication is total. We search for the cause of the universe because our minds are built by evolution inside a universe of strict, linear causality. But the mathematics of spacetime does not guarantee that causality is universal. The universe may have had no first cause, not because it came from nothing, but because its origin was structured as a loop in which first and last, cause and effect, beginning and birth, were all the same moment, viewed from different positions on a closed curve in time. Number 1. Holographic projection. Perhaps the most radical departure from traditional physics requires us to view the Big Bang not as a physical explosion, but as a sudden, massive processing event. The holographic principle, an offshoot of string theory and quantum gravity, originated from the study of black hole thermodynamics. Physicists discovered that the total information content of a black hole, its entropy, is not determined by its 3D volume, but by the 2D surface area of its event horizon. This led to a sweeping generalization about reality itself. The three-dimensional universe we perceive might simply be a projection. All the volumetric data, the depth, the matter, and the interactions we experience could be fully encoded on a distant, two-dimensional boundary surrounding the observable cosmos. Apply this principle to the origin of the universe, and the narrative fundamentally shifts. The Big Bang ceases to be a sudden clustering of physical particles expanding outward. Instead, it becomes the dawn of a complex decoding process. Consider a dormant substrate of raw, primordial, two-dimensional quantum information. There is no space, no volume, and no arrow of time. Then, a phase transition occurs within the fundamental data structure. The mathematics initiate a rendering sequence. The flat, static information suddenly begins to project mathematically outward, weaving the illusion of three spatial dimensions and establishing the forward momentum of time. The intense heat, the rapid expansion of inflation, the subsequent cooling, and the clumping of matter into galaxies were not physical collisions in a void. They were the highly complex execution of a cosmic algorithm. The Big Bang was the moment the projector turned on, translating an infinitely dense, flat field of raw data into the rich, volumetric, gravitational reality we interact with today. We, and everything we observe, are the active, continuously processing manifestation of boundary mathematics, playing out across a holographic theater that sparked to life 13.8 billion years ago.